Okay, so let us talk about the fundamental theorem of proportionality. It states that if a line is drawn parallel to one of the sides of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Okay, before understanding the statement, what does it mean to say and how will we derive the theorem, let me go through a few of the basics that will be useful for you to understand the fundas very easily. First of all, there are three types of triangles as we know: an acute angled triangle, a right angled triangle, and an obtuse angled triangle. Now for this case, we are interested in finding the height or altitude of the different types of triangles. Okay, for example, for an acute angled triangle, the height is always in the inside, in the interior of the triangle. In a right angled triangle, one of its side itself is the altitude or height of the triangle. But in case of an obtuse angled triangle, the altitude may be in the exterior of the triangle. Let's keep this in mind. अब चलते हैं derivation की ओर. The statement as it says, there is a triangle. In our case, let the triangle be A, B and C. And if now there is a line which is parallel to one of the sides, matlab from this AB, BC and AC, let us say that there is a line which is parallel to one of the sides, that is BC. हम लोग BC को parallel एक line draw करते हैं which divides the other two sides, that means the side AC and the side AB, which divides the other two sides at distinct points. Distinct points का नाम दे देते हैं. Let us name it as D and E, this point and this point. So in triangle ABC there is a line. Let the line be called L, इसका भी नाम दे देते हैं. So in a triangle, a line which is parallel to one of the sides intersects the other two sides at distinct points. तो क्या होता है? Then the segments that are formed are in equal ratio. कौन से segment? This AD upon DB, I'm going to write it like this: AD upon DB is equal to this side's segments ratio, AE upon EC. AE upon EC. This is what we want to prove. अब कैसे करना है? चलिए शुरू करते हैं. Okay, so let us now start deriving the formula. For that, I need you to understand the construction of the diagram. This is the diagram A, B, C, the triangle that is required. One of the line which is parallel to one of its base, that is BC in our case. The name of the line is L. It divides the other two sides at two different points, that is D and E. Now I want you to construct BE. I want you to join the line segment from B to E and from C to D. And one more, I want you to construct a perpendicular from the point D to the line AE, to the side AE. Want you to construct a perpendicular from D to the side AE. As it is perpendicular, I am showing it by a symbol. In a similar way, I want you to construct a perpendicular from the point E to the side AD. Similarly, I'll draw a perpendicular from E to the side AD, and again it is a perpendicular, so we will show it symbolically. And now let us name the points as, for say, P and Q. The two new points, let us call it P and Q. This is the construction of the diagram. Okay, now I want you to focus on a pair of triangles, that means two triangles at a time, ABC, DE, a perpendicular Q, a perpendicular P, this joined with this point, and this is with BE. Okay, now focus on two triangles. I'm writing the name over here: triangle ADE and another triangle BDE. That means the upper triangle ADE and the triangle BDE. this left side triangle. And similarly, for the second case, we are going to take the same triangle for the first case, that is ADE. ADE remains same in both the cases. Triangle ADE, you have to take it, you have to consider it both the time. So triangle ADE, and another triangle is CDE. That means for the second case, I am going to take triangle ADE and triangle CDE, the triangle at the right side. Is this getting clear? Okay, so I'm going to take those two triangles separately now. For the first case, the triangle that we have selected is the triangle ADE. If you look at the triangle, it is an acute angled triangle, and I have already said in the beginning that for an acute angled triangle, the height is in the interior. For our case, it is EP, or it may be taken as DQ, whichever you like. But as we have selected the triangle on the left hand side first, BDE, so I would choose the height as PE, this for this triangle ADE. Now, if you take PE as the height, then you have to consider AD as the base. If you consider PE as the height, then you have to consider AD as the base. For finding the area of a triangle, if you write the formula, the area of triangle ADE will be equal to half multiplied by the base multiplied by the height. Let us keep this in mind, half into AD into PE. Let us take the second triangle. The other triangle looks like this. I'm going to draw that part only which is required right now. The triangle BDE, the second triangle that we want to consider is the triangle BDE. Now, if you look carefully at the triangle BDE, it is an obtuse angled triangle. And as we know, the height of an obtuse angled triangle is found in the exterior. So, if you just extend the side BD and you see that this is the height of the triangle that is in the exterior, the height is PE, that is in the exterior, and the base considered will be BD, because for finding the area of a triangle you take the base corresponding to the perpendicular height, the altitude. So for triangle BDE, the area will be half multiplied by the height, that is PE, multiplied by the base, that is BD. Again, we will remember this, half into PE into BD, and the area of triangle ADE is half into AD into PE. Now let us take a ratio of the area of these two triangles. ADE upon BDE. This is equal to half multiplied by AD multiplied by PE divided by this is half multiplied by PE multiplied by BD. Half PE gets cancelled, so we have now we have AD upon BD. ADE upon BDE is equal to AD upon BD. Now similarly, we have to take the other two pair of triangles that we have already selected, that is ADE, and the other one is CDE. I am going to draw the part that is only necessary, CDE, these two pair of triangles. Now for this, let us write the area of triangle ADE. Now for this case, as we have selected the triangle on the right hand side, we will consider the height on the right side, that is ADE. We'll consider the height DQ for this case. So we will write the area as half into base. The base will be considered as AE, half into base into height, that is DQ. Let us keep this in mind, half into AE into DQ. Now let us look at the other triangle, that is C, D and E. Again, if you look at the triangle, it is an obtuse angled triangle. So if you extend this side CD and you find the height that is in the exterior, that will be DQ. So the area of CDE will be equal to half multiplied by the base multiplied by the height. So again, we will keep this in mind. The area of triangle ADE, half into AE into DQ, and the area of triangle CTE half into CE into DQ. Now let us take again the ratio of the area of these two triangles. ADE upon CDE, that is equal to half multiplied by AE multiplied by DQ divided by half multiplied by CE into DQ. Now whatever cancels, DQ, so we have AE upon CE. Let us just write it like this. ADE upon CDE is AE upon CE. Now we are going to recall one more funda. If there are triangles which are lying on the same base and between the same two parallel lines, then the area of those triangles are equal, right? Remember this? So if you look at the diagram that we had initially, what will we find is that the triangle BDE and the triangle CDE. That means the triangle BDE and the triangle CDE. They both lie on the same base DE and they both lie between the same parallel lines DE and BC. So what? Area of BDE must be equal to area of CDE. Is this correct? And in an acute angle triangle that we had ADE, no matter which altitude you take, the area remains the same, right? So ADE is equal to ADE. It is simple and easy to understand. We can write ADE equals to ADE. Now the ratio that we had in the two equations, the first one was ADE divided by BDE and the second one was ADE upon CDE. Now just now we have established that ADE is equal to ADE, the same triangle, and BDE is also equal to CDE. Why? Because it is lying on the same base between the two parallel sides. So the area, the ratio of the area is equal. Now the next step would be this ratio of the sides, ADE upon BDE. As we remember, ADE upon BDE is equal to AD upon BD. So let me just quickly write there. ADE upon BDE is equal to AD upon BD and ADE upon CDE is AE upon CE. Hence, this is the result that we are looking for. Thank you for your time.